And then the team decided to call him Smart Bob. So I didn't know if I should take that personally or not. But, so this is Smart Bob. What's that make me? I don't know. But this is a teaching device for nurses and doctors, people in the medical industry. And this is obviously using technology on the Windows platform for doing three-dimensional rendering in this 2D format. But what we also want to demonstrate today is what we call Hololens. So Hololens is what's referred to as a mixed reality device. A mixed reality, who here's put on the VR goggles, right? So what does a VR goggle when you put it on? You're totally immersed in the digital world, right? In this case, this is taking 2D and 3D graphics and overlaying it on the real world, so you can still see where you are. So it's being used by doctors in surgery to take imaging, and let's say they're doing back surgery, they'll have the patient back in front of them, and then they'll be able to overlay exactly the three-dimensional imaging of their body and make it and be able to pinpoint exactly where they're going to make the incision for the back surgery, things like that. In this case, this is a tool that's demonstrating how, in a teaching mode, Dave's going to take what looked like it was inside of Bob. Now it's exploded out and floating above, so you can see skeleton, muscle, organ, and circulatory systems. And now Dr. Mushorn can walk forward. See, watch, he walks forward, and he can, and now all, he can basically immerse himself and in this information. So this is an example of how this is being used in the real world. And it's using the same technology that's used to develop Xbox games or mobile games on your phone. It's the same tool. So if a developer knows how to use Unity, that's the name of the tool, they could use, they could create an application on Unity. They could use a C# language or Java or JavaScript. They can use basic graphics, or we just announced, you can now use the Unreal Engine. And if you're familiar with the Unreal Engine, it's the one that's used in the most advanced games today that makes, you're playing a game on a PS4 or Xbox, and it looks like the real world, real rocks, real grass, everything. That's the Unreal Engine. So now you could use that to create the graphics that will run on the headset. That's a full-blown Windows computer. The most advanced part of this, though, are the lenses. The glass that's in here took us years to develop that. It's very advanced, and we're about to come out with version 2 later this year, HoloLens 2. Yeah, go ahead. Yes, you can, absolutely. I want everyone to be able to try it on.
Why are they, why did they take so long to develop? So
the ability to generate a hologram in front of your eyes, based on taking in the real world. So it actually has sensors which are examining the real world and measuring everything, so it knows where everything is. It knows there's a wall there, a floor there, a chair there. So it figures all that out. So that's from a camera perspective. And then being able to project a 3D graphic in a place that you want in that real world. So it's the lenses to produce that effect, very advanced. So it's a lot of composite engineering goes into that. Composite in the term of the elements that go into the glass.
Yeah, because Amy, it's not like a typical AR thing where you're just looking at the camera and you're looking at a screen and the camera's producing the image on. You're looking at what's really out there and the image at the same time. So it's like, how do you make a screen that you can see through in places where you want to see through it, and then but it's projecting something where you don't want to. Yeah, it's fancy stuff.
Okay, now look at over here. And now you just exploded it.
How do you guys solve the alignment problem? Like getting the image to line up with Bob here.
How does it feel, Lauren? Lauren, how does it feel?
It's so cool. Oh my goodness.
Now imagine they're using this today to train doctors and nurses. They're using this on manufacturing floors for training. so that the person who's learning how to put the product together is seeing what the next step is. They're seeing the thing they're supposed to do. It's in 3 dimensions floating above the product as they're making the product. There's like tons of applications for this technology.